Hey guys, um, you should have taken your first quiz. Hopefully you did well. If not, come in and get a little extra help. It's not the end of the world. Remember, quizzes are a smaller percent of your grade. It's just a opportunity for me and you to kind of figure out where are you at. Where do you think you're at compared to where are you really at? So just come on in, get a little extra help on that, and yeah, make some progress. Tests are worth 60%. So that's a heavier toll if you don't do well on the test. So just rally and get those pieces of the puzzle put together where they're supposed to be. All right, we're starting a new one, section 1-4. Complete different break from section 1-1, 1-2, 1-3. Different language and all that. So if you're getting a little exhausted with all that graphing talk, you're going to make a change. All right. And it starts out pretty simple. So, but there's some tricky stuff to understand, and most of it has to do with your understanding of the vocabulary. So, you can see the first thing listed here is this or phrase, arithmetic sequence. What the heck is an arithmetic sequence? Well, if we take a look at example 1, you can see 12, 16, 20, 24, question mark. Well, really, you're just looking for a pattern. You have to be careful. That's why I have 3 different examples. And also, they're going to ask you, what is the common difference? Now, that gets a little tricky, but if you have a plan, it's not that big of a deal. And then they ask you, what is the next term? That's pretty easy once you realize the pattern. And as you can see, pretty simple pattern. 12 plus 4 is 16. 16 plus 4 is 20. 20 plus 4 is 24. So we could quickly just say, for number 1, the next term is 28. And yes, it's considered an arithmetic sequence. Because you noticed there was one consistent number that you would add to each previous number, and it develops that pattern. Keep that in mind. Now, what is the common difference? Well, from 12 to 16, you would say, aha, the common difference is 4. And then you'd move on to the next problem and you'd think, well, what's tricky about that? Well, how did I get the 4? Well, mathematically, here's the first item in the sequence. I'm going to take the second item, and I'm going to subtract the first item, and then I get 4. Now you're thinking, whoa, you're making that way too hard. Well, here's why I'm making it, giving you a rule here. This second example, look at it. Is there a pattern from here to here that's the same from here to here, that's the same from here to here? Yes, there is. Now what's happening? Notice this is going up 4, and that's pretty consistent with what's the common difference. This one is actually like temperature going down 1. So down 1 degree, down 1 degree, down 1 degree. You can see the pattern. What's the next term? Well, that's pretty easy. Now, what is the difference? Well, some of you might say 1. And that's not going to be correct. Because as you notice, this in this sequence goes up. Therefore, it's a positive difference. This is actually going down, so it's a negative difference. So that would be -1. Now, if we stick with the formula way of doing it, we would take the second number in the series, just like we did here, -7, and subtract the first. Isn't that just -7 plus 6, which is -1? Now, and again, you guys are like, well, which way do you want me to do it? It doesn't matter, as long as you look at it properly. An easy trick is, if it's going up, it's going to be a positive difference. If it's going down, it's going to be a negative difference. Now that's oh, I'm sorry, I almost forgot example 3. Now notice, I put this on here because it's a matter of semantics, or it's a matter of wording. Look, 7 to 9, I'd add 2. 9 to 12, I'd add 3. 12 to 16, I'd add 4. Like, I'm going to add 5, and my next number is going to be 21. Now that's a pattern, but the problem's not asking you find the pattern. The problem's asking you, is it an arithmetic sequence? See, this is consistent. It's the same. This is consistent. It's the same. This is not consistent. Therefore, it disqualifies itself as being an arithmetic sequence. It has a pattern, but it doesn't fall into that definition of being an arithmetic sequence. I'm going to pause it for a second. Okay, moving on to the next topic. Not really a new topic, it's just a different way of looking at the thing we just looked at. So now as you can see, I've got arithmetic sequence versus not arithmetic sequence. Now in the previous examples, there were just lists of numbers. Same thing, we have a list of x's, a list of y's, a list of x's, a list of y's, input, output. Just to make sure you're thinking properly, when I say input, like this, if x is 1, if I put x is 1 into the equation, this mysterious equation, it's going to pump out y equals 5. And another way of looking at it is, if I put 1 into the function defined by f, it's just this generic term for some equation, y would equal 5. Different way of saying the same thing. So with that being said, if we look at it, like, is this an arithmetic sequence? Well, if you look at the x's, that's clearly going up by 1, but the real focus is right here. This goes up 4, this goes up 4 from 5 to 9, this goes up 4, this goes up 4. So we're like, hey, that seems to fall in line. Yes, this is an arithmetic sequence. Check mark means good. Let's go to this one. This is 1, 2, 3, 4. So we're like 1, 2, 3, 4, 5. We're like, yeah, that's a pattern. But this is up 3. This is up 4. This is up 5. This is up 6. Definite pattern, but this is not an arithmetic sequence. So we can throw that out. Now, when you say yes, it's an arithmetic sequence, that means, now I've already jumped ahead a little bit. I've plotted 0, 1, 1, 5, 2, 9. And as you can see, it forms a line. You know what that means? It's a linear relationship. This f is going to be a y, or f of x equals mx plus b. Now I want to show you a little trick. We've already realized that it's definitely an arithmetic sequence. But now look, I'm just going to randomly pick this one. What times 2 gives me a number either equal to 9 or a number underneath 9? The first number underneath 9 that I can multiply this number by to get something would be a 4. 4 times 2 is 8. And then I need to add 1. Well, let's see if that pattern is the same. What times this? Now you'd say, well, 5. But let's see if this pattern here, 4 times my input plus 1 gives me this. Let's try it this one. 4 times my input, what's that? 12. 12 plus 1 is 13. 4 times my input, that's 16. Plus 1 is 17. Let's see if it works for this one. 4 times this is 4, plus 1 is 5. How about this one? 4 times my input would be 0, plus 1. It works. So what I'm saying is, and this is what I would say more challenging, because you have to recognize the pattern, you need to practice this, would be y equals, my slope is 4 times my input, and then I add 1. Now what if you're saying to yourself, whoa, I don't know if I would be able to pick up on that. Well, you notice I plotted these points here. What did I say the slope was? Well, it's the pattern we realized, but what if it just doesn't pop out at us? Well, if we plot, minimally 2 of these points, now I'll go from here to here. Now I could go from here to here, I could go from here to here. I'm just going to pick these 2 points. Remember how you find slope? x1, y1, x2, y2. And I'm going to use the formula, y2 minus y1 all over x2 minus x1. And I'm just going to follow the formula. So y2 minus y1, x2 minus x1, and I get 4 over 1, which is just 4. Now, if you remember, this is my slope. So I would say, aha, y equals 4x. Uh-oh, I don't know what my y-intercept is in this situation. Sure you do. It's right here. 0, 1. If x is 0, y is 1. It crosses my y-axis right there. So I go y equals 4x plus 1. So here's the thing. There's going to be problems that come at you. I'm kind of surprised in this homework assignment. I haven't found one yet. But there's questions like ACT, SAT, which they'll give you this sort of list, and then they'll say, what's the output for the input of 100? So they're saying, okay, you just kept going, and you put x equals 100 in, they do not expect you to keep going with. 5 would be 21, 6 would be 25, and until you get to 100. They're looking for a shortcut, and this is the shortcut. So if x is 100, and I put it in here, I get y equals 4 times 100 plus 1. That'd be 401. Now, I made it look easy, but each problem would be a little different. Now, I haven't found a problem like this on your homework, but I'm going to try to make one up for you so that you have an opportunity to practice this, because I think this is money, okay? So we're going to hit pause. All right, final chunk here. And this chunk is asking us to find what the arithmetic series is. That is not the same thing as, is it a sequence? We'll talk about that, but let's just dive right in. Let's look at the straightforward question. Example 1, what is the sum of the terms in the arithmetic sequence? See, they're already telling you it's a sequence, but you can see up by 3, up by 3, up by 3, up by 3. So there's the consistent pattern. And if I was to do this problem, I'd say, oh, that's 1 plus 4 plus 7 plus 10 plus 13. That's 23, 30 plus 5 is 35, and that would be my answer. Now, the question is there an easier way to do it? And the answer is yes. They have a formula for you. I'll give this to you. This right here means what's the sum? This right here is the number of elements or items in your problem. So in this case, there's 1, 2, 3, 4, 5. So that's saying find the sum of those 5 elements, but they're also telling you let n equal 5. So I'm going to take that out, and I'm going to put a 5 right there. Now what is this? Well, that right there is the first term in your list. So I'm going to take that out. I've got a 1. What's this? Well, that's the n is 5. That's just a way of saying in this list, the last term is 13. So I'm going to replace that with a 13, and now it's PEMDAS. Please excuse my dear Aunt Sally. We've got to do parentheses first. 14, so that's 5 times 14 over 2, which is 70. That's what this times this is, over 2, which is 35. Now I'm going to pause this real quick. I was just running out of time. I've got like a minute and 10 seconds, so I want to make sure to be efficient with this. So the question is, why would you ever use this formula? Well, if this list has 100 terms in it, boom, this formula is your buddy. But if you just want to add these up because you understand what the word sum means, which, by the way, it means the same thing as the word series. Find the series. So here's the question, worded like a math problem. Find the arithmetic series. We go, aha, that's the sum. If you don't know that, this problem's hard. If you know it, it's super easy. Now, I'm not going to add these up by hand. I'm just going to throw this in there. 1, 2, 3, 4, 5, 6. So that's 6, which tells me this is 6. My first term is a 2. My last term is a 22. And then I just do the math. That's 6 times 24 divided by 2. Now I'm going to divide this and make that 3, and that would be 7.